Okay, we'll look at that question, but first I was going to kind of go over the notes part of it real quick. It won't take long, but the non-repeated linear factors, what they're referring to right here is that you could factor this right here, the denominator. That would factor into x minus 3x plus 1. And those are known as being linear because you won't have a power any longer. Like linear just is like, x minus 3, and then the other one's x plus 1. So if there's not a power, those are known as linear, and they're non-repeated because they're not the same. So then let's look at an example of the repeated one. Oops. Okay, so in this example, you have repeated ones. So I do have the power of 2, but it's the same factor over again, and it's linear because it's like x minus 2 times x minus 2, right? If you were to break it apart. And so that's what's kind of going on there. And also here you can see in this example, they have repeated the x plus 1 to the power of 3 is repeated. Um, and then let's look at the irreducible. So the non-repeating. So what this is basically, see the x squared plus 2, that's a quadratic factor because it has the x squared. And so I can't break that apart into multiple factors, and it's not reducible. Um, And then let's look at the repeated one. And so the only difference is now I got the power on the outside. So I got that quadratic factor twice. I've got the x squared plus 4 and then x squared plus 4 again because of the power of 2. So now let's go ahead and look at the quiz question. And so it wants us to go ahead and label these as what type they are. And so if you look at this, I'm going to go ahead and put parentheses around this. And so that would fall into the non-repeated irreducible quadratic because it's a quadratic and it's does not repeat and we can't factor it. So that's going to fall into number 3 right here. Okay, and the next one's kind of boring because it's pretty much the same problem. So if you look here, you can't factor it, so it's just going to stay there. So it's non-repeated irreducible quadratic factor. Um, so that's a 3 also. Now, just being the devil's advocate real quick, if it would have been x squared minus 16, and then we could have factored that into x plus 4, x minus 4, then it actually would have fallen into the non-repeat linear factors, if that would have been the case, but I couldn't do that, so. Okay, then let's look at the next one. So that one is going to be a repeat of linear factors because what I can do is I can break that apart into x times x, and so each one of those is known as a linear factor. And then if we look at the next one, actually it's the same thing. Those are linear factors because you can break them apart, and so it's a repeat of the same factor 2x plus 5 over and over again. Then let's see this one right here. It's a quadratic. So right now you know that automatically, and it's not factorable, so it automatically narrows it down to 3 and 4. And so it's a repeat. You can see that the power right there indicates that it's the same factor multiple times. And so that's going to fall into category 4. And then, oh, here's an example kind of like what I was looking for earlier. So if you look at this factors into x plus 2 and x minus 2, and those are linear factors, but they're not the same, so they're not repeated. So those are non-repeated linear factors. So that's going to fall into category 1. And then let's see the next one, that's quadratic again, and it's not factorable, and so it's raised to a power of 5. So that means we have repeated irreducible quadratic factors, and so that's going to be 4. And then the last one is going to kind of be like the one up here where it looks like this is factorable. This can factor into, let's see, what is this? X minus 6 and x plus 4. So they're non-repeating linear factors, but they factor into linear factors. So that'll fall into the first category type. So, well, I hope that clears some of that up for you. And if you have more questions, feel free to send them.